Welcome students. So now we are going to discuss about the a numerical example on eigenvalue and eigenvector. How to calculate eigenvector. Okay. So what I have told in the previous video that if A is given, system matrix is given, first we have to calculate the lambda. That means the eigenvalues, and then we have to proceed for the eigenvectors. I will show you the methods. So let us first take an example. The example is A let us A equal to 4, 2, 3 and 3. So now what you have to do, you have to find the eigenvalue as well as eigenvector. So what we found? We found for eigenvalue the equation is Ax equal to lambda x, where lambda is the eigenvalue and x is the eigenvector. So what we have to do? We have to take identity matrix over here. So we have to multiply the identity matrix lambda I into x. So we can able to take it in the left hand side. So it is happening as A minus lambda I into x equal to 0. Okay. Or you can write it as lambda I minus A into x equal to 0. Both of the cases will work. Okay. So now, and this is actually the characteristic equation. Which is the characteristic equation? Lambda I minus A equal to 0. That means you can get lambda I minus A equal to 0 or x equal to 0 to satisfy this equation. So from the lambda I minus A, it is known as characteristic equation. So the characteristic equation is lambda I minus A equal to 0. So A is known to you. You have to find lambda. So lambda into identity matrix, as it is a 2 cross 2 matrix, naturally identity matrix will also be a 2 cross 2 matrix. So this is the identity matrix. Okay. Minus A. What is the A matrix? 4, 3 and 2, 3. Okay. So now this is equal to 0. Now if you take the equation, it is becoming lambda here and lambda here. Okay. So that means it is becoming lambda here and lambda here. So this is the first one and this is the second one. 4, 3, 2, 3. So now if you subtract these two matrix, the elements of the matrix, so we are getting lambda minus 4, here minus 3, and then it is minus 2 and it is lambda minus 3. Okay, lambda minus 3. So that means this is the expression. Okay. So what we have to find? We have to find the determinant of this matrix. So determinant of this matrix is becoming, so the determinant of this matrix is becoming lambda minus 4 into lambda minus 3 minus 3 2s are 6. Okay, so this is the determinant. So if you multiply these two factors, we are getting lambda square. Then we are getting that it will be minus 7 lambda and 3 4s are 12. That means plus 12. Okay, so it will be lambda square minus 7 lambda plus 12 minus 6. So the final expression is coming lambda square minus 7 lambda plus 6. Okay. Now what we have to do, so this will be equal to 0. So we can write here that lambda square minus 7 lambda plus 6 is equal to 0. So we can get the value of lambda. Okay. So what we have to do, we have to take, if I split this in form of lambda and lambda minus 6, then I can write it as lambda square minus lambda minus 6 lambda plus 6 equal to 0. So we can take the common lambda minus 1 minus 6, this is lambda minus 1 equal to 0. So lambda minus 1 into lambda minus 6 equal to 0. So therefore the factors, the lambda has two values, as it is a 2 cross 2 matrix, naturally lambda should have two value. So we are getting the value of lambda is equal to 1 and 6. Okay, so the eigenvalues of the system, we got the eigenvalues of the system. In the previous video, I told you that first we have to get this is the first step, that is we have to find the lambda values, okay, eigenvalues. So the first step we have done. Now we have to go for the eigenvectors. Okay, so now we have to go for the eigenvectors. So what is the expression? Expression is lambda I minus a into x equal to 0. So as two values of lambda are there, we will try to for each and every value we are try to get the eigenvector. If the value of lambda is 1, what is the eigenvector we are going to get? And if the value of lambda is 6, what is the eigenvector x we are going to get? So let us start that procedure. So the next step is what we are going to do. We are going to find the value of eigenvectors. So eigenvectors are basically for two values of lambda we are going to do is 1 and 6. So let us start with 1 first. Okay, so for lambda equal to 1. So for lambda equal to 1, the expression was our lambda I minus a equal to 0. Okay, so here the value of lambda will be 1. Clear? So that means our general expression of lambda I minus a was lambda minus 4, and it was minus 3. This was minus 2, and this was lambda minus 3, right? So this into, so now it is a 2 cross 2, naturally x will be x1 and x2, the values of x vector. Okay, this will be equal to 0. So what we are going to do, we are going to put the value of lambda equal to 1 here. So if I put the value of lambda equal to 1, I am getting it is minus 3. So putting therefore for value of lambda equal to 1, I am getting this is equal to minus 3. This is also minus 3. This is minus 2, and this is also minus 2. Okay. Okay, now in case of doing the eigen, when you are going to get the eigenvector, what you have to do, you have to make a row. That means you have to take one, and other row you have to, by using operation, using transformation and operations of matrices, you have to make one of the row equal to 0, whatever you want to do. In any row, you can do it as per your choice. Okay. So I am considering, suppose this is by certain operations, I am making this row equal to 0. I can do that. If I take this and if I just add it with the R1, it will be 0. Here also that is true. Okay. So that means we are going to make first, what is the thing that we have to make a row 0. Okay. So if a row is 0, only one equation will remaining. So what is the equation? The equation, if this row becomes 0, if I make this row equals to 0, so what is remaining? The equation is becoming minus 3x1 minus 2x2. Okay, that will be equal to 0. This is your expression. Clear? So from here you are getting that this 3x1 equal to minus 2x2. Okay. Now what you have to do, you have to we have to take a common factor, so that we can take a common. Okay. So what we are going to do, this 3 and 2. What is the common? If I multiply this with 2 and if I multiply with this with 3, they both will become 6. Okay. So what I am going to do, I will write that, let us no need to write this line, just so what we are going to consider, that let us consider x2 is equal to 3, x2 is equal to 3 into k. Okay, x2 is equal to 3 into k. So if you consider, you have to consider something here. So if x2 is equal to 3k, if you substitute here, what is x1? So you have to, what you have to do, you have to find the values of x1 with respect to some common factor. That common factor is k. Let us consider the value of x2 equal to 3k. How you will determine that it will be 3k? You try to make the common factor, try to make the number associated with x1 and x2 same. Okay. For that, excuse me, what you have to take? You have to take that, if you want to make it 6, then you have to take this will be equal to 3k. Okay. So what I am going to do, if x2 is equal to 3k, then what is the relation with the x1? So this means this 3x1 equal to 2 into 3k equal to 0. So that means we are getting that x1 is becoming minus 2k. Okay. So if you write, so you are getting two values, x1 is equal to 3k and x1 equal to minus 2k and x2 equal to 3k. So what is your eigenvector over here? x1 and x2. So your eigenvector will be minus 2k, 3k. That means if you take k common, then it is becoming minus 2 and 3. So this is the eigenvector for lambda equal to 1. Now what we are going to do, we are going to apply the same process for lambda equal to 6. Okay. So when lambda is equal to 6, what is our expression? You just put the value of lambda equal to 6 in the general expression. You will find it will be 6 minus 4. So it will be 2, then it is minus 2, then it is minus 3, and it is also plus 3. Okay. So this is our expression. Here it will be x1 and it will be x2. This is equal to 0. Now for this lambda equal to 6, you have to find the eigenvector in the same way. What you have to do? You have to take any one of the row equal to 0. Either this or this. So let us take this. I am taking this equal to 0. So what it is coming? It is coming. You can take this is also equal to 0. No problem in that. Same thing will come. So what you are going to do? I am considering that this is equal to 0 and it is becoming 0 and 0. So what is our equation? 2x1 minus 2x2, this is equal to 0. So I told you that we will try to make these two factors equal to same. So here they both of them are same. So I am considering that x1 equal to k. Okay, x1 equal to k. So if x1 equal to k, then what we are getting? 2 into k minus 2 into x2 equal to 0. So from here we are getting that x2 equal to k. We are getting x2 equal to k. So now what is your eigenvector? Your eigenvector for lambda equal to 6 is becoming x1 and x2. 1 minute. x2. So x1 was equal to k and this is also equal to k. So that means if you take k common, it is becoming k into 1 and 1. So these are the eigenvectors for the system. Okay. These are the eigenvectors for the system. So if you have to find eigenvector, you have to follow this procedure. First you have to find the lambda for each and every lambda. For that is the value of lambda. When the lambda is equal to 1, what will be the value of x? That you have to find. When the lambda is 6, what can be the eigenvector? You have to find. If it is a 3 cross 3 matrix, naturally for lambda, another value of lambda, you have to find the eigenvector. Okay. So for different lambdas, you have to find the eigenvectors and that will be your answer. Okay. So this is how to find eigenvector. Thank you. Happy learning.